Hi all, welcome you back for yet another episode on petroleum refining. So far we have seen how the crude oil is distilled in a petroleum refinery and how various petroleum products are manufactured. We have also gone through the different offsite systems that are helping the refinery to run in a seamless fashion. Today, we are going to talk about the various kind of equipment and their maintenance strategies. Specifically, we are going to see fixed equipment and rotating equipment and the various maintenance strategies like breakdown maintenance, preventive maintenance, predictive maintenance, and turnaround maintenance. So let's see the different kind of equipments in our refinery. Of course, refinery is a asset intensive industry. So many equipments are there, starting from pumps, compressors, heat exchangers, furnace, fired heaters, distillation columns, separators, and it goes on like anything. Broadly, these equipments are classified into fixed equipment and rotating equipment. As the name suggests, rotating equipments have rotary parts or parts that are moving, while fixed equipments there are no moving parts. So generally the fixed equipments are prone for corrosion or thickness degradation, etc. Whereas the rotating equipments are subject to several other disturbances and repair issues. Let's try to understand more. First, let's try to understand the different kind of equipments used in the petroleum refining industry. First, let's start with the pump. Pump is the most commonly used item in the petroleum refinery. The purpose of pump is to move fluids such as liquids and slurries from one place to the other place. So normally it is also used to pump out liquid from a column to another column or to the storage tank. A pump displaces a volume by physical or mechanical action. So generally pumps are almost 90% of the pumps are driven by electrical motors, but there are cases where the pumps are also driven by turbines. So the major categories under pumps are centrifugal pumps and positive displacement pump. So we are not getting into the details of the classification of the pumps. We have to understand that the pumps play a crucial role in every section of a refinery. A compressor is an equipment that increases the pressure of a gas by reducing its volume. So this is also a classic example of a rotating equipment. Compressors are similar to pumps, both increase the pressure of the fluid and both can transport the fluid through a pipe. But generally pumps are meant for transporting or pumping out liquids, whereas compressors are meant for moving gas or vapor. Compressors are also, like pumps, are categorized as centrifugal compressors and reciprocating compressors. So compressors generally have lot of moving parts and hence they are provided with a lot of adequate safety mechanisms like vibration monitoring, etc. So those things are adding to the compressor to safeguard its safe operation. Then motors. An electric motor uses electrical energy to produce mechanical energy, very typically through the interaction of magnetic fields and current carrying conductors. Motor is one of the prime movers of any rotating equipment like a pump or a compressor. So again, there are several classifications under motors like induction motor, series motor, squirrel cage motor, etc. But in today's episode, we will not get into those details. We have to remember that motors are one of the prime movers of any rotating equipment like pumps and compressors. Then comes the turbine. A turbine is a rotary engine that extracts energy from a fluid flow and converts into useful work. I think all of us would have studied about hydraulic turbine which are fitted in a dam where the stored water is used to produce electricity by rotating the water turbine. Almost in the similar manner, here in the refinery, the turbines are driven either using steam or high pressure hydrocarbon liquid. The simplest turbine have one moving part, a rotor assembly, which is a shaft or a drum with the blades attached. Moving fluid acts on the blades or the blades react to the flow so that they move and impart rotational energy to the rotor. Generally, in a refinery, turbines are part of the power and utilities department, and their main purpose is to generate power with the help of an alternator. But there are few turbines available in the process plant to drive the pump. In case of power failure, the pump can be still continue to put into operation. In a refinery, you will be able to see different kind of pipelines making crisscross flow. Their purpose is to transport oil or gas from one location to other or from one system to another system. In a refinery, almost 40% of the investment is on pipelines, apart from the other equipments like pumps, compressors, heat exchangers, etc. And a pipeline in the oil and gas industry, the size of it can vary from quarter inch to 32-inch also. And most of the pipelines are made from steel, but there are places where even you can find copper tubing. The important aspect about a pipeline is the pipeline integrity always need to be checked. So otherwise a pipeline can leak and it can create a potential safety hazard. So whenever we think of pipeline, we have to remember about pipeline integrity. Then comes the heat exchanger. Heat exchanger is a classic example of static equipment or fixed equipment. That means there are no moving parts. So it is primarily a shell kind of arrangement within which you have a bundle of tubes. It is a device built for efficient heat transfer from one medium to another. For example, when you want to send a crude oil to the furnace, you want to reduce the load of the furnace. In order to achieve that, we try to preheat the crude oil in a set of heat exchangers, and they are known as preheat train. And where do they get heat from? They get heat from the different kind of products that are generated from the refinery. So the products lose heat and then they are cooled and then taken to the storage for safe storage and handling, while crude oil picks up the heat so that before it goes to the furnace, it is already preheated and so that the furnace load can be reduced. So all this is possible because of the set of heat exchangers. Typically in a refinery, crude oil is preheated by the hot products using a set of heat exchangers. So again, there are multiple varieties of heat exchangers are there by terms of their way they are constructed or the way the flow is happening. The common example of a heat exchanger is shell and tube heat exchangers. So again, based on the flow inside the shell as well as the tube bundle, there are multiple configurations available. Then another important equipment inside a refinery is a fired heater or furnace. A fired heater or a furnace is a device for heating the crude oil, and the furnace can also be called as the fired heater, used in boiler applications in refineries. So here primarily the furnace is having burners which can take fuel oil or fuel gas as the source of fire. So the heat from the burners are transferred through convection and radiation to the process fluid, either crude oil or any other product, and finally the temperature is achieved. So in fact, in the crude distillation unit, the atmospheric furnace, the temperature of the crude oil is heated up to 350 to 370 degrees centigrade, depending on the types of the crude oil. So here the furnace has got burners, stack, chimney or refractory lining. So periodical inspection of the furnace is important for an uninterrupted operation of the fired heater or furnace. Then we come to the distillation column. Distillation column is the most important equipment inside a refinery. For every refinery, at least one distillation column need to be there. If at all, if the crude is sweet and very light, one column is sufficient to produce different kind of petroleum products from the crude oil. So then that kind of refinery is known as topping refinery. But most of the refineries across the globe, we have complex refineries. When we have complex refineries, we'll have multiple distillation columns. We'll have one distillation column in the crude distillation unit as atmospheric distillation column, then vacuum distillation column, then LPG stabilizer will be there. Then for FCC unit, we'll have a main column. There are multiple distillation columns available here. So it is primarily an fractionating column and essentially used for separation of liquid mixtures into its component part or fractions based on the difference in their boiling points or volatilities. A distillation column would have several trays, downcomers, etc., so that the vapor and the liquid can travel from up and down. We move on to separators. A separator is just a large drum. Most of the time it's an horizontal drum designed to separate production fluids into their constituent components of oil, gas and water. At different stages in refinery, the oil, gas and water, they need to be separated, and this is accomplished by the help of a separator. So obviously the gas being light, it will gather on the top of the separator and then it will be taken out from the top exit of the separator. Water being the heaviest amongst the hydrocarbon and the water, it will settle down on the bottom of the separator and it will be continuously drained out. Then the liquid will be taken to the further processing. It works on the principle that three components have different densities which allow them to stratify when moving slowly with the gas on top, water on the bottom and oil in the middle. And based on the operating pressure, the separators are classified into high pressure separator, medium pressure separator and a low pressure separator. Then we have storage tanks. So I think we have already discussed about storage tanks in some of the previous modules, but we will also cover something more in this module. A storage tank is a container usually for holding liquids. For liquid fuels, there are fixed roof tanks and floating roof tanks. Basically, there are the two major classifications, fixed roof and floating roof. Fixed roof tanks are meant for liquids with very high flash points, that is fuel oil, water, bitumen, etc., which will have less volatility. While floating roof tanks are used for liquids with low flash points, example, naphtha, aviation turbine fuel, motor spirit, ethanol, etc. Then we have the pressurized storage tanks which are meant for storing certain hydrocarbon which are liquid under pressure. For example, LPG, butylene, propylene. So the pressurized storage tanks can be classified into two categories. One, bullet, the second one is spheres. Since LPG, propylene and butylene are stored under pressure, the shape of the bullet and the spheres can withstand the pressure. If it is not having a symmetrical dimension, then the pressure will be different in different place inside pressure of the vessel. That is why a cylindrical storage known as a bullet or a sphere is used for storing liquids that are under pressure. Then we have reactor. So reactors are again essential part of a refinery. Many a times the crude oil or the hydrocarbon fractions may have to undergo a lot of chemical reactions. These chemical reactions are possible inside a reactor. Most of the time the catalyst inside the reactor, it is available in the form of a fixed bed. Special design considerations are taken to design a reactor. Reactor consists of a catalyst in the form of a fixed bed or a moving or fluidized bed. Cylinder filling carousel. So this is the tail end of the refinery. Once the LPG is stored in the storage facility, from there the LPG is taken to the cylinder filling carousel, using which we fill the LPG into cylinders that can be used as a domestic LPG. A filling carousel is intended for filling LPG in large groups. It consists of a frame with the running wheels, rails, a central column for LPG and air, and a driving unit, the carousel frame around the central column. So, even in our domestic walk of life, when we have so many appliances, they are bound to get repaired. So, if we don't get repaired, then we are put into hardship, or sometimes some of our activities are coming to standstill. So, imagine the plight of the equipment repair in a refinery. So, if a pump fails and if it is not attended immediately, then it is going to tell upon the performance of the refinery. So, obviously, all the equipments are to be properly maintained in a proactive fashion, or if at all if something goes wrong, immediately action need to be taken to restore it back to the normalcy. So, otherwise the refinery will be running, the refiner may be producing petroleum products, but the petroleum products may not be meeting the specification of the market. So, these maintenance methodologies are broadly classified into number one, breakdown maintenance, which is also known as reactive maintenance or corrective maintenance. The second category is preventive maintenance. Third one is predictive maintenance. And finally, the fourth one is turnaround maintenance. Breakdown maintenance. So, this is a maintenance which is required when an item has failed or worn out to bring it back to the working order. Breakdown maintenance is also known as reactive or corrective maintenance, most commonly used approach inside a refinery. So, this is almost similar to what we do at our house. When one of our home appliances fail, then we take it to the shop and then get it repaired. So, the same manner, there are certain equipments which will be taken care with the help of breakdown maintenance strategy, and it is the most commonly used approach, but it has got a lot of limitations. So, what are those limitations? When an equipment fails, it often leads to downtime in production, and sometimes it causes spreading a damage to the other parts in the refinery. In most cases, this is costly maintenance approach. Also, if the equipments need to be replaced, the cost of replacing it alone can be substantial. Breakdown maintenance is the first and foremost type of maintenance strategies. So, in this breakdown maintenance, reliability of the systems maintained by this type is not known and it cannot be measured. Hence, this approach is carried out on all items where the consequences of failure or wearing out are not significant and the cost of maintenance is not greater than preventive maintenance. The next one is preventive maintenance. Preventive maintenance is the care and servicing by personnel for the purpose of maintaining equipment and facilities in a satisfactory operating condition by providing for systematic inspection, detection and correction of incipient failures either before they occur or before they develop into major defects. Preventive maintenance includes testing, measurements, adjustments and parts replacement performed specifically to prevent faults from occurring. So, preventive maintenance can be described as maintenance of equipment or system before fault occurs. For example, if a refinery has got 500 pumps or 500 rotating equipments, under preventive maintenance strategy, each day there will be a schedule and each day 100 different type of pumps will be tested. The primary goal of this type of maintenance is to avoid or mitigate the consequences of failure of equipment. This may be by preventing the failure before it actually occurs, which is planned maintenance and condition based help to achieve. Preventive maintenance can be further classified into two categories. One is condition based monitoring or risk based inspection. Under condition based monitoring, so generally the rotating equipments are subject to condition based monitoring. So here the technician will collect the vibration data of a pump at a specified interval, and based on the analysis of the vibration data, the prediction would happen whether the certain pumps can be repaired or overhauled. So based on that, the decision would be taken. So here in this condition based monitoring, in the recent years there are extensive instrumentation that are being employed along with the tools and analyzing the condition data. Risk based inspection is primarily meant for very sensitive equipments like the reactors or the transfer line of a furnace. So using different gadgets and sophisticated equipments, the thickness of the particular location is monitored, and based on that it will be predicted whether this equipment is going to fail or not. Predictive maintenance is the next category or next development. So based on the past data and using a lot of data analytics tool, you will be able to predict whether this particular equipment is going to perform without any issues for the next 6 months. And if at all, if there is a setback identified, then accordingly the maintenance strategies are defined and then it will be taken into action. So that is known as predictive maintenance. The last category of maintenance is turnaround maintenance. It is a planned periodic shutdown. So normally that happens every 3 years or 4 years depending on the size and throughput of the refinery. So during turnaround maintenance, there are several activities that will happen. For example, heat exchanger cleaning, the distillation columns, trace cleaning, or any modifications or any debottlenecking activities, that is to identify the limitation of the plant and then remove the limitation by putting additional facilities so that the throughput can be improved. Turnarounds allow for necessary maintenance and upkeep of operating units and are needed to maintain safe and efficient operation. Turnaround maintenance are scheduled at least 1 to 2 years in advance and do not necessarily focus on the same operating units. Depending on the process unit and the amount of maintenance needed, the length of the turnaround can vary from 1 week to 4 weeks or more. And there will be a lot of contract workers who will be performing several activities during a turnaround maintenance. During turnaround maintenance, there is every likelihood for incidents to happen. The safety incidents can happen. So in order to avoid these safety incidents, safety is given the prime focus during the turnaround maintenance. In today's episode about equipment maintenance, we have learned that petroleum refineries are asset intensive industry, and the equipments are categorized into static or fixed equipment and rotating equipment, and the various maintenance strategies employed are breakdown maintenance, preventive maintenance, predictive maintenance, and turnaround maintenance. So with that we conclude today's session. So let's catch up with another session in the next episode. Thank you for watching this module.